This is U4 C6L7, multiplying and dividing inequalities. Here's Mr. Romanovich.
Hello! The conversation that just ended between Mrs. Benoit and I ended like this. So, it's not about winning or losing when you have an argument. It's more about who gets to be on camera. So, I won. And I'm glad you can't hear her in her snide remarks. We're going to be multiplying and dividing inequalities. This is the big boy and big girl stuff here. So I can find a solution set for one-step inequalities. It is a solution set. It's no longer just one answer. It is a solution set of answers that go off infinitesimally. I'm going to keep practicing that word in these videos as best I can to the chagrin of my colleagues. Go ahead and look those words up too. Okay, here's our problem. We're going to solve graph then check, and we have 8x is less than 40, and I know what you're thinking is, Mr. Romanovich, I've got this in the bag. This is the easiest thing in the world. We, of course, draw our wall, and because we're doing multiplication, we're going to undo multiplication with division, and all I did was make this into a simple fraction where 8 divided by 8 gives me 1 over 1, leaving me just x. Bring down my inequality sign. 40 divided by 8 is 5. X is less than 5. Then my next step, of course, is to graph it. Here is 5 and a point after it and a point before it. We have 4, 5, and 6 on the graph. Go back and check my inequality sign. It does not include a greater than, or it does not include an equal to sign. So I know this is going to be an open circle. And then make sure when you're doing these, you're not using like a 4th grade trick of saying, oh, well, it points that way, so I graph it that way, or a 6th grade trick. Make sure you're actually reading it. So it's x is less than 5. So if it's less than 5, I know it's the numbers that are less than 5. So we do not include 5 because there's no equals to. And we draw the arrow going off to the left. Now, as Ms. Benoit likes to say, here's everybody's favorite. Pick a point that is in the solution set or the shaded area. That would be 4. Let's just choose 4. If we put 4 in for our equation, we have 8 times 4 is less than 40. 8 times 4 is 32. Less than 40. You're darn tootin'. Wow, that was bad. That checks. There you go. Everybody appreciates a darn tootin'. So that's what you end up with, and then you know their solution is correct there. So now here's where it gets fantastically more fun. So we have negative 2g is less than 10. We're going to do the same process. We're going to solve graph then check. We'll start with our wall, of course. And the thing that we've got to remember now is that there's a negative involved. And this negative we have to deal with. We have to deal with it with multiplication and division. And because of that, it's going to add a slight nuance to what we're doing here. We see multiplication here, and we need to divide by negative 2. It has to be a negative 2. These negatives are important now. Negative 2 divided by negative 2 is a positive 1, because we need that g to be positive. But if we're going to do that to one side, we have to do it to the other. So let's divide by negative 2 here. And 10 divided by 2 is 5. Check your signs. Are they the same or different? They are different signs, which means it ends up being a negative 5. Now, when you multiply or divide both sides by a negative, your inequality sign is going to reverse. So I'm going to write the word reverse here. Right? Because I'm dividing by a negative on both sides. Which means this sign, when I rewrite it down here for my solution, looks like that, a greater than sign. Here it's a less than sign, then it turns into a greater than sign. And if you want to prove it to yourself, get your solution set and draw it incorrectly. And you'll see exactly what I'm talking about. But for this, let's graph this one. Let's get our horizontal line. Here's our negative 5. That's our solution. And now we need a number before and after. So let's take a negative 4 and a negative 6. And then looking back at the symbol here, it is a not equal to symbol. It's just greater than. So we're going to use an open circle. And then since it's greater than, we're going to the right. So it's going to be all of these solutions. So now let's test it. Here's the key. Now the check becomes vital. We have negative 4. Let's put negative 4 in for our g. So now we have negative 2 rewrite your equation here. Times negative 4 is less than 10. Negative 2 times negative 4, multiplication of negative integers gives us a positive. 2 times 4 is 8. Both signs are the same, which means it's a positive, which gives us 8 is less than 10. And we know that's true. 8 is less than 10, so that checks. That's a way better check than my first one. All right, let's try one more, because everybody loves the math. Here we have x over negative 3 is greater than or equal to 4. I always think these are easier, so try to see this as being easier instead of seeing the fraction bar and thinking more difficult. So for this, if we want to get rid of a negative 3 in the denominator, we need a negative 3 in the numerator. So we're just going to multiply both sides. Let me erase that black line. We're going to multiply both sides by negative 3 over 1. And you're all screaming at your video screen right now saying, Mr. Romanovich, what are you doing? You forgot to try the wall. So there's the wall. Are you happy? Okay. So if we're going to multiply by negative 3 over here, we've got to multiply by negative 3 over here. And I'm just going to keep it as a negative 3. I'm not going to turn it into a fraction because this isn't a fraction either. And what I do know, too, is that when I do this multiplication, I end up with negative 3 in the numerator or negative 3 in the denominator, which equals 1, leaving me just x. That blue is no good. Leaving me just x. And then I have 4 times 3, which is 12. They're different signs, which makes it negative 12. And what I know from the last slide was, if I'm multiplying or dividing by a negative, this sign has to reverse. Okay? And if this sign reverses, it goes from a greater than or equal to a less than or equal to. Now, once we get to that spot, we're not done. 2 steps left. We've got to prove this answer. So let's draw a graph. Here's our negative 12. Here's our negative 11. Here's our negative 13. Check back to your sign. Your sign is a equal to, a less than or equal to, which means we're going to use a closed circle. So let's get that dot right there, closed circle. And then x is less than or equal to negative 12. So less than negative 12 means we're going to the left. So all of this is shaded in. Now, do we believe it yet? No, because we still have to do the math. So this is going to be the challenge part. So we're going to end up with a fraction here, but let's look at it and see if we can figure it out. We're going to take negative 12 and put it in for our equation. So we have negative 12. No, we're not using negative 12, are we? We're using the first one in the solution set. So we use negative 13. Erase that. Negative 13 over negative 3 is greater than or equal to 4. So now we got to use some logic. So how many 3's fit into 13? We have a negative divided by a negative, so our answer is going to be positive. We know that from Unit 1. How many 3's fit into 13? Well, it's more than 4. We know it's going to be 4 and what? What would it be? 4 and 1/3? Yeah. Because 4 times 3 is 12, plus 1 is 13. 13 thirds. The other way to check this would be, and we know that 4 1/3 is greater, let me just finish this. 4 1/3 is greater than 4, right? Now, my question is this. So I'm going to get Mrs. Benoit about this. Mrs. Benoit, do you think that we could turn this 4 into an improper fraction with negative 3 as the denominator?
Yeah.
Or is that too far?
I think what you showed is probably good enough.
Okay, we can go with that.
Yeah.
All right. Sure, you don't, I'm really curious about it. All right, fine, we won't do it. All right. And what we know is that 4 and 1/3 is greater than or equal to 4. And we know that because we did a simple conversion of this improper fraction to a mixed number. And we know that a negative divided by a negative would give us a positive. So we know that's a positive as well. So this one ends up being, thankfully, for Mr. Romanovich, correct. All right, here's your targets. Yoing. Your 2 targets problems are this. So you got to solve graph and then check these. Negative 4x is less than 40, or k over 2 is greater than or equal to 9. It's good to practice this, so make sure you practice well. If you have any questions, ask me, ask Ms. Benoit, ask Ms. Purdue, ask Ms. Benashunas, ask anybody in the math department. We're here to help, usually. Good luck.